look at your minor axis length of 8. The entire length of this axis is 8. You want half of it. Half of it is your B. So if the whole thing is 8, half of it is 4. So B is equal to 4. You didn't have to find your covertices, but these are where your covertices exist. All you had to do was take the 4 and plug it in for B. So this is your B squared, there's your 4 squared. And then just plop your center in it. 9 plus 4, square the bottoms, and you come up with your equation for your ellipse. Okay. Can everybody do this? Can you tell the difference between the ellipse and the hyperbola? What's the major difference? The adding and subtracting sign. The second major difference is it doesn't matter what order the ellipse comes in. A is the larger number. The hyperbola said order matters because it's a subtract. Order matters. A is the first number.
When there's an ellipse, the x always has the A on
No. When it's an ellipse, the larger one is the A, the major one. So if it's oblong lengthwise like this, then the X is the A. If it's oblong this way, then it goes under the Y.
And then when you have the axis length, you always find that too?
Yes, because they give you the entire length of that axis. Your center is in the middle. All your measurements are from center to an endpoint. Center to an endpoint. Those are your measurements. The center to the endpoint. Even your foci, the center to the foci, always from the center. Every once in a while, they'll throw like a foci length at you, but not too often, because that really doesn't make sense to do that. Mostly they give you an axis, a minor axis length, or a major axis length. They won't really throw that one in at you, because there's really no way to call that. This parabola you didn't have to do. Here's a hyperbola. So as soon as yes. 126. Was that more important than this? Yeah? That was bothering you? Okay. All right. Are you telling somebody to meet you here at 126? Okay. All right. So hyperbola. Hyperbola, I start like this. Minus. Just start it like this first. Once we find the transversal, because we only have one axis that it goes off of, once we find that, we might have to interchange these two. Because if it goes off the y-axis, then the y has to come first. If it goes off the x-axis, then the x has to come first. But the minus has to stay in the middle. So we find our center, -2, -1. And we find our vertex. Oh, that means I'm going off my translated x-axis. If my vertex is along this line, it doesn't matter how wide it is, that means my x comes first. Here's the case, Alex, that this is the A. A is always first in the hyperbola. You remember it this way. Order matters. So the major one goes first, the A goes first. Now, I work the difference here. The difference between -2 and -7/4, which is -1 and 3/4, is 1/4. So A is equal to 1/4. Then they didn't give me anything else. So I can set this up so far. I can put that in there, and I can put in A. I still need to find B. Remember, you have to square it. And 1/4 squared, 1/4 times 1/4 is 1/16. Now to find B, sometimes they give me a foci, I can use my formula. Sometimes they give me an asymptote, I can use my slope. Remember slope like this first. Don't remember it with the, you're going to remember the square root of the y, square root of the x, but don't do the a and the b until you set this up. It's y over x. So find what's under your y. Underneath your y is b. Underneath your x is A. So set your slope of 4 equal to B, which I don't know, over A, which is 1/4. Now cross multiply those. So B is equal to 1. And when you put b in your squared one, you just get 1. So here's my formula, my equation. Now technically, you shouldn't leave a fraction in the denominator. You should multiply the top and the bottom by 16 to get rid of it, which flips the 16 on top. If you left it like this with a fraction, for the hyperbolas and the ellipses, I'm okay with it. We never leave a decimal or a fraction in the denominator, but our goal when we do an ellipse and a hyperbola are to take the square root of that to find our distances. So if you leave them there, it's not a bad thing. Okay. Everybody see the difference between this and an ellipse? And an ellipse, guys, you're just going to make your ellipse within here. Your ellipse is going to be right in that little space, rather than the box. It still has the vertices, and it has kind of like the co-vertices, if you call it a co-vertices. It would be the oblong one because your b would be greater if it was an ellipse. Well, Mr. Corn. Good, how are you? Aaron? Yes. Yes, okay. Yes, I can send him down. Where in? You're in the girls' gym. Okay, no problem. Okay, bye-bye. Aaron, in girls' gym. Oh, is that why you had to tell your coach where to call? So that was your phone I was hearing? Good luck. Go to the mobile area to make sure you walk through these problems because the test is Monday. Okay. All right. And this guy too, you had to find the hyperbola centered at the origin. That's nice. And the intercepts are along your x-axis, which means they're going off the x. So right away, start like this: x squared, y squared. You don't need any plus, you don't need any plus h, minus h, whatever. This guy has to come first. And we know our hyperbola gives us a minus sign. So start like that first. Your center is 0, 0. We took care of our HK. Your A always comes first, and it went off the X, so the X has to come first. So the distance from here to here, this is your vertex point, is 3. So A is 3. Now, it also gave us an asymptote. Now, the asymptote, you can even graph here. Your asymptote goes up to over 1. Okay, up to over 1. Now it's going to do it again. Up to over 1, up to over 1. It's going to do it 3 times. So, do you see where it's going? Up to, there's 3 of these here. So it can only go over 1. Up to over 1, up to over 1, up to over 1. And it crosses right there. So it went up 3 times of 2. There's your 6. So if you can see it on your graph, that's nice. If not, use the fact that your slope is your change in y over change in x. Your slope is 2. The y is the b. The x is the a. So we know a. We just don't know b. So cross multiply, and b is 6. And then don't forget to square them. They're squared in the numerator, they're squared in the denominator. And sometimes you can see it on the graph. Chris?
So when they give us the asymptote, just use that,
This,
just change one.
yes, the slope. The change in y over the change in x is your square root of your y denominator over the square root of your x denominator, isn't it? But I'm trying to make it like so that you remember way back, slope has not changed. Slope is still change in y over change in x. So the goal is to find your y denominator and take the square root of that, b. Find your x denominator, take the square root of that. That a and b will change on a hyperbola. We don't need it on an ellipse, but it will change on a hyperbola depending on which one is first. So yes. That's the horizontal. That's your major. That's your transversal.
And then the y equals 2x still, you just put it as like, if it was like 2, the y equals
The m is 2. Slope is 2. Your intercept for your y is 0. This is y equals mx plus b. So it's crossing through the 0. All you care about on that asymptote is that slope. don't care about where it crosses. That's why we're able to use it. Sometimes when it's not centered and they give us something like this, 4x minus 7 like the last one, we didn't care about this. We only cared about your slope. That's the only one we cared about.
Okay.
And sometimes you can kind of plot it off of your graph. And sometimes it doesn't fit nicely, then you know you're ending up with a fraction. Okay, take a look at this. I have tons of reviews. Okay, you want to find the equation of an ellipse. So start with your x minus h squared, y minus k squared with a plus in the middle and your denominators. And then you're given that the foci is on the x-axis. Oh, so it's on the x-axis? So this guy is your major. X is your major. So this gets the a squared. This gets the b squared. That one's going to be longer. The major axis has to be bigger than the minor axis. And the x-intercepts are actually here at negative 12 and positive 12. So this is your center at the origin. This piece here gives you A. So A is 12. Your major axis length is 24, but A is 12 from the center to your vertex. Your y-intercept is here, up at the 4, at the negative 4. So this piece right here is 4. There's your B. That's all you needed. You don't need your C, you don't need your foci. They did tell you that your foci was on your x-axis. Well, they told us where our vertex were too. But that leads you to believe x is your major axis. So plug it in and you should get your equation. Okay? This guy, we recognize this to be, without even me telling you, could it be a hyperbola? No, why? It has an add sign. Good. Could it be a circle? No, because why? The y and the x have different coefficients. They'd have to have the same coefficient to be a circle. And a circle is a special ellipse. You can solve a circle just like you solve an ellipse. So we know it's an ellipse, and we need to set it equal to 1. So we divide everything by 324. And now we've got our a squared and our b squared. Our center is at 0, 0. This guy has to be the major because it's larger. It's going more around the oval. The biggest oval is the x part. So we go over 6, vertex, over 6, vertex, up, co-vertex, down, co-vertex. We can find your foci points by your equation. You have to know those two. Now, the only difference between the ellipse and the hyperbola is the ellipse subtracts it because it wants to come inside of your ellipse. So it has to take A and subtract B from it. A is where it goes to the vertex. So it has to subtract to come inside. Now, the hyperbola is coming on the outside. So it's got to add to get further past that vertex point. A is your vertex point. Right? And remember, when you have a radical, such as radical 27, you have to reduce this first. But since you're adding and subtracting from here, instead of saying, you can say 0 plus or minus 3 radical 3, 0. And since you're adding 0, you can even just cut it down to this. Here's your foci points. If you leave the 0 plus, I'm fine. Chris?
When I wrote my braces and co-braces, I just did the plus or minus.
You did what?
Like you said, you wrote it out.
Yes? You did plus or minus? Oh, that's fine. That's fine. Yeah. The only thing that would get you in trouble is this. If you had to say, like, your center was at, say, 1, 1. I don't want to see this. Then I want to see 7, 5. Yeah. But the plus or minus, absolutely. There's nothing else. Yeah, that's fine. Yes. Because we knew we had to use this equation. So we plugged it in, and we got C is equal to 27. We took the square root of 27. And then we came here. Perfect square, not perfect square. We reduced it, we simplified it. So the perfect square, the 3 comes out, and radical 3. It's just simplifying your radicals. Just like you would simplify your fraction and get it reduced to those terms, we do that. Don't use your calculator to give me decimals though. Okay, that was a parabola. Here's an ellipse. When it says your minor length of your axis is 4, that means half of it goes from the center to the covertice. So half of it is 2. That's your B. Your center and your vertex have to fall on your major axis. That guy's got to be bigger. So right away you're going to set it up like this. Plus, I like to set up my standard look. And because this is my major, there's the A. So then I work with it. And easiest way is also to write your pieces here and write this guy here and work this way. I'm going from -7 to 0 and 1 more. I went 8. Because if you subtract the negative and you forget to change the sign, you're going to get 6, not 8. So look at it logically. You went 7 positions and 1 more. Up, A is 8. Then half of this guy is 2. That's all you need. All you need. And you can plug it in. Good? Okay. This one. We did number 5. Find the equation satisfying an ellipse. Everybody okay with that? It seems like I like a lot of the X major axes, huh? Maybe my parabolas work out better when I draw them that way. Major length of 10, cut it in half. 5. And parabola. These I just wanted you to get used to identifying them. Now, what you want to do is put them on one side. If it's a parabola, you're only going to get one square. Anything else, get them to one side. So this one, you move to this side first. You can see the plus sign. You can tell right away it's either going to be a circle or ellipse. But because the coefficients are different, it's an ellipse. No. But you have to do this anyway to determine, like when you have to complete a square, you're going to have to determine it anyway. So I just wanted you to kind of get used to eyeballing these. Put this y to the other side, or even if you put this x there and that y there, you're still going to end up with a minus, right? A minus gives you a hyperbola. We move this over. This is a circle. It's also an ellipse, special case of ellipse. These two both are circles, but they're special cases of ellipse if you wrote ellipse. Absolutely. Okay? And what I want to do today is complete a square with you so that everybody can complete a square. Not a hyperbola. All right. If you looked at this equation, what would you say, which conic would you say this is? Ellipse. Ellipse because what? Plus. And your two coefficients are different, right? Now, we have to group this for over completing the square. So let's rewrite this with the x's together, then the y's together, and move the 61 over to the other side. Okay. We've got to set this up as an ellipse. You told me it was an ellipse because you saw the plus, and you saw that this guy had a 1, this guy had a 4. So my ellipse formula has to look like this. I must have a center other than 0 because I have to complete the square, and I have to decide where A and B goes. But I got to get that completed the square look here. So this one's okay. I can section this out, leave myself a space to complete the square. This one, the coefficient has to be a 1. So what am I going to factor out? 4, not the y, just the 4, because you want to be able to complete your square. Plus 8y plus something. I got 2 plus somethings on that side, so I have to have them on the other side as well. So now we can complete your square. What's half of negative 2? Negative 1. Squared. What's negative 1 squared? 1. I put it here and here. So I'm getting there. I got that part. Plus, when I put the 4, what's half of 8? 4. So, y plus 4. What's 4 squared? 16, but it's trapped inside my parentheses. So I got to distribute it back out. So if I multiply that, I get 64. You okay with that? So it's getting to look like that, right? It's getting there. I add these together. So I have a negative 61 and 1 gives me negative 60, and a positive 64 gives me a 4. But I noticed that I have to equal to 1. So what am I going to divide by? 4. One step at a time, guys. One step at a time. So, yes. Because 4 squared, we take half of 8 to give us 4, and then 4 squared gives us 16. So we're here. Plus, out comes the 4, but keep the 1 in your denominator. Equals 1. So I'm getting to look like that now. Which one is my major axis? X, because it's the larger number. A, B. Okay, what's A? 2. What's B? 1. What's my center? 1, negative 4. Good. God bless you. So I should be able to find 1, negative 4. Make my translated axis. Off with my x. I'm moving my x, guys, 2 positions over. 2 positions over. So let me use my graph. I'm changing my x 2 over. So if I subtract 2 from 1, where's that put me? Negative 1, negative 4. That's a vertex point. And if I add 2 to 1, where does that put me? 3, negative 4. Okay? B, my minor axis, is going up and down 1. If I go up 1, this is my co-vertex, what's that at? 1, negative 3. If I go down 1 to my other co-vertex, what's that at? 1, negative 5. So now I know my co-vertex is at 1, negative 3 and 1, negative 5. Here's my ellipse. There's my ellipse. Where does my foci sit? Along which axis? The major. So here, somewhere, is my foci. Equal distance away from my center. So I use my formula. C squared equals A squared minus B squared, because I want it to come inside. So here's my A squared. 4 minus 1 equals C squared. So C is equal to radical 3. Okay? Is that a security guard?
Yeah. That's the first time in a row.
Alright, one more thing, guys. Let's get this in. I need to find my foci point. So I'm going to move radical 3 just like you moved to the left and to the right. So we're moving your x value. So I'm taking my x value of 1 from my center and adding and subtracting radical 3, and my y value is negative 4. You can leave your foci points just like that. You don't have to separate them. If it was like a 1 or a 2, then yeah, you'd have to add and subtract it. But at radical 3, there's nothing else you can do to it. Okay? So can everybody complete the square? And find the rest of the pieces once you complete the square?
You say you found the co-vertex, isn't that the C?
No, C is your foci. Your A is your distance from your center to your vertices. Your B is the distance from the center to your co-vertices. C is the distance to your foci.
This one.
Mhm.
So how do you know which one's the exact square?